Hello everybody, welcome to another video. It's been a while, but here I go again. And in this video I'm going to talk about Azure Synapse Analytics. So what is that and why am I talking about it? Well, Azure Synapse Analytics is a service I came across by accident. It wasn't something that I was looking for or planning to work with or let alone do a video on, but I came across it because I am finishing up my master's in computer science, and for my capstone project there's some machine learning that I have to do, and read data, run some algorithms over it, make predictions. And I was having the darndest time trying to get an Apache Spark instance running. I tried installing it on my Windows machine. That didn't work out too well. I didn't want to use the one for the school because it wasn't interactive. I had to SSH and then transfer files, and it was all command line, and I'm not a data engineer, not a data scientist. I don't want to muck around with all that. I just wanted something that was more interactive because I really am new to this, and so ideally something that would run in Windows, and I could have an editor like Visual Studio Code, and where I can just run my machine learning algorithms and see the output. Just wanted to get my dang work done. And so I looked around and I saw this Azure Synapse Analytics. And so what is it? Well, that's one of those things that the more I look at it, it seems like it's hard to explain what it is, but to me, it's just basically a way to easily get an Apache Spark cluster up and running so I can do my work. And that's what exactly happened. I was really impressed by the ease which I could just spin up a Spark cluster and write my Python code and get my data in there into Azure, and just run my code and just see the output. And it really sped up my workflow and reduced the amount of toil that I experienced. And so I just wanted to share what I've learned so far with using Azure Synapse Analytics, and specifically with its Apache Spark capabilities. So let's deploy our Azure Synapse workspace into Azure. And what I'm showing you here is the repository that contains all the deployment scripts and code that you will see in this video and stuff that you won't see in this video. I will put the link to the repo in the description of this video. So I made this really easy to set up. All you have to do is run one script and it will set up your Azure Synapse workspace. So I'm just going to go through this step by step just to show you that it works. So the first thing we need to do after we clone the repository is go to the repo root and then log into Azure. So I have my PowerShell window here. So I'm just going to do an AZ login and pick my account and then close that tab that opens. And great. Okay, and now I have to get my subscription ID because that's a parameter to the script. So that AZ account show. That's my subscription ID. Okay, so let me then run this deploy script and passing it in the subscription ID. Actually, yes. Paste. Okay. There we go. All right, so this is going to take about 10 minutes or so, I'm going to pause the video and resume when the deployment script has finished executing. Be right back. All right, the deployment is complete and no errors, which is good. So on the left-hand side here, I have the resource group that the deployment created. And the resource group that the deployment script creates has a Synapse POC prefix followed by a random string. So that's how you can find the resource group. Just look for the one that starts with Synapse POC. And there's 3 resources created. The first one is a storage count, and this is actually a data lake. So this is where all the data files are stored. And then you have the Synapse workspace, which we'll get into here in a bit. And then the Spark pool, and the Spark server is the server that will do the data exploration and analysis. All right, so we'll go back to the right to the output of the deployment script. This is the link to the workspace URL, so all we have to do is click that, and then the workspace will open in the browser. But before you do that, if you're going to try this at home, and the Python notebooks that I'm going to show you has a variable whose value you have to set to this file system endpoint. And of course, it's going to be different for you, but make sure you set that variable, else the code won't be able to find data. If you look at the README under this Open the Azure Synapse Workspace section, you can see your URL and the file system endpoint, and it says, note, you'll need the file system endpoint value when running the notebooks. And in the run the basic notebook and the k-means clustering notebook, it shows you what to do with that value. And in a second here, I'm going to open the workspace up and then run both of these notebooks so you can see what it looks like. All right, so let's open our Synapse workspace. So I'm going to show you the end result of this demo. And this is what you see here is called the Azure Synapse workspace. And the workspace is your IDE. So it's your one-stop shop for your code, data, and compute. So on the left-hand side here, you see data. Data is where the data for that you need to analyze is kept. This is actually stored in an Azure data lake. Develop is where you put your code, and the code are usually files called notebooks. And in this case, I have Python notebooks, although you can also write them in other languages like Scala, Java, and even .NET. And then manage is where your compute is managed. And in this case, the compute is a Spark cluster, which was created as part of that deployment. So let's go to develop here. So I have 3 notebooks, and the basic notebook, you just click on it to open it. It just provides basic code that does data exploration. And so I already ran this, so there's output, but I will run it again. So all you have to do is, well, actually, important thing here is you need to change your file system endpoint to match your file system endpoint. If you actually run this on your own, it's going to be different. And the output of the deployment that we ran contains the value that you have to put here. So if you look at the output, the last line, it's going to be dfs.core.windows.net. And the first part's the name of your file system, and the second part's the name of your data lake. And so that's how it'll find the data. So let's look at this data totals folder, what's in there. So if we go to data, and then you'll see you may have to expand this Azure Data Lake Storage Gen 2. As I said, all the data that was uploaded as part of the deployment came into this data lake. And then you expand this tree till you get to this file system node, and you click that, and that's where your files are located inside data totals. Again, you may have to drill down into the data and then into the totals folder. But this is all a bunch of CSVs, and this CSV is basically statistical information on basketball players from 1969 all the way down to 2021. And the data files came from basketballreference.com, and I have put the attribution in the description of this video. So I hopefully won't get in trouble for using this, but if you use it, just use it for your own educational purposes and not for sale or any kind of commercial use, because that's against their terms of service. All right, back to Azure Synapse. So that's the data, and then we can go to manage, and you can see, you click Apache Spark Pools. You can see the Spark pool that was created as part of the deployment. And it's a small 4-core 30 gigabytes. It's the smallest node you can get, and you have 3 of those. You can also create SQL pools and Azure Data Explorer pools. So depending on your familiarity with, if you're not familiar with Spark, but you can do your analysis in SQL Server or Azure Data Explorer, you can just easily create pools from this IDE, which is also a great thing about this Synapse. And that's what I mean by one-stop shop. You don't really have to leave this IDE to do your data analysis. All right, so let's go back to develop, and I'm just going to run this basic notebook just to see, show you what happens. So after you put in your file system endpoint here, you should be able to run all. If you run this for the first time, it's going to have a little warning here that says specify a Spark pool to attach to. So then you go to drop down and just select your Spark pool. And then you can click run all. And my Spark pool at this point is starting, so it's going to take several minutes for the Spark cluster that we just saw to start and all the code to run. So I'm going to pause the video and return when all the code in this notebook has executed. All right, the notebook has finished executing, so let's go see what the output looks like. So the cell right here, cell number 12, just shows you the career stats for every player that was found in those CSV files. And the cool thing about Apache Spark is that you can display the data in a very nice tabular format. So this is pretty cool. By default, Spark's output is not this pretty. But you can also use Python libraries to generate diagrams. So here I'm using Matplotlib, which is a very popular plotting library for Python. And this is just a histogram of the number of players and years played. So you can see most players playing, I don't know, 1 to 2 years, 3 years, less than 5. The majority of players played less than 5, so careers aren't that long. As you can see here, very few people make it past 20 years. The other cool thing about the built-in Synapse tables is you can also view them as a chart. So if you click chart there, you can see you have various types of charts. If I go here to view option, yes, you can specify your chart type. So you can also do a histogram from here, or a line chart, pie chart, whatever. So this is a really good thing, especially if you're not familiar with this Matplotlib. And there's just 4 or 5 lines of code, but still it's something that you have to know how to do. But if you don't want to go through all that, you just want to see your data visually really quickly, Azure Synapse provides great support for that. Okay, now let's go to a more complicated analysis where we actually do some machine learning. So click this k-means clustering, and I'm not going to go super deep into it, but k-means clustering is just a way to it's a way to group data. So I don't know, an analogy I can think of is I'm holding a jar of M&Ms, and then I'm throwing an M&M at you. You catch it, and then you got to figure out, okay, how can I group it? So as I keep throwing M&Ms to you, and you keep catching them, hopefully, you can take these M&Ms and start grouping them together. And after 1,000 or so M&Ms, you'll have distinct groups, and then you look at the groups and make some inferences about them. So the question is what would you group it on? So in the case of an M&M, would you group it by the size? Well, you could do that, but then M&Ms are more or less the same size, so you just have 1,000 M&Ms in one group, and so you can't really, make any inferences aside from the fact that all the M&Ms are the same size. But what if you did like color? So color might be better because there's several M&M colors, and so you group them, then you'll have groups of colors. But still, maybe might be more useful to group them by size and color, because then you can maybe get like some M&Ms that are smaller, and maybe those are defective. So that's the idea. And so in this case, the features or attributes, features or attributes, they're synonymous, that I'm using are shown in figure 5 of the first cell. Points per game, rebounds per game, assists per game, and years played. And no, my final project for my master's degree has nothing to do with basketball or clustering, in case you were wondering. So yeah, I'm just going to run all again. And again, before you run this on your machine or your Azure environment, make sure you update your file system endpoint. So this should be the same value as it was here in the basic notebook. They should match. All right, so I'll go ahead and run it. And I think this should be a little faster. No, I guess I thought it would be faster because the pool already started, but still taking a bit. Okay, so sometimes you get this. Okay, so in this case, you have to restart the cluster. So let's do that. I'm actually going to close this notebook. Whoops. And I'm going to stop the session. Let's just close and discard the changes there. And close this tab too. Okay, so I'm going to try running it all again. And I'm going to pause it while the pool starts, and when the notebook's finished executing, I will resume the video. Be right back. Okay, the clustering notebook has finished executing, so let's just see what we got. So in this cell, the output is the player name or the player's ID, and the prediction is which group the algorithm says they're in. So as you can see here, in group 1, you have Vince Carter, Dirk Nowitzki, and Kevin Garnett. Interesting. And so you have another cluster number 5, which has Kevin Willis. Don't know who that is. That's Jamal Crawford. Sudonis Haslam, and that's down here, Jawan Howard. Okay, interesting. So I told it to make 6 clusters, I believe. So if we scroll down, can scroll down, and we see these, 6 clusters, and this is what's known as a parallel coordinates plot, as you can see here on line 5. And this is another plot provided by Matplotlib. And this is a good way to visualize multiple attributes in a single graph and see relationships. So here you can see in cluster 0, points per game, the range is, about 3 to about 10. And the rebounds per game from close to 0 all the way up to about 10. Assists per game, that's the range, and years played, that's the range. So as we see, cluster 1 was where Kevin Garnett, Dirk Nowitzki, Vince Carter were in, and we could see that all the players, have some common characteristics, and this is where the inferences about your clusters come into play and how useful this data is. So you can see here that all these players are high scorers. Because if we look at the points per game, there's nobody even really close except maybe cluster 4. And they also have a pretty decent amount of rebounds as well. So they're high scoring and pretty good rebounders, and also, the assists are also pretty good. And they've had longevity for the most part. A lot of them played several years. So, these are like probably the Hall of Fame, all type of players, all-time NBA types of players, right? And then you go to cluster 3, and they're kind of like, they haven't played very long and they don't score, rebound, or so it's probably just marginal players who lasted a very short time in the NBA. Maybe they went to the G League or maybe went overseas. I don't know, something like that. And then you have, and this is also interesting, number 5. They played, for a good amount of time, and they had pretty good assists and rebounds, and they also scored too. So I would say these are kind of the well-rounded players. They're probably the kind of the dependable ones. If you have high scorers, all-time Hall of Famers like Michael Jordan, these are probably like your Scottie Pippens. It's interesting. I'll see if Scottie Pippen is in this group, but I won't do it in this video, but that's something you can do. If you look at the code, there's examples of how you can get a particular player in the cluster he's in to see. But I wouldn't be surprised if Scottie Pippen was in cluster 5. Yeah. So, that's about it. And, it's really cool as you can get really into this and start looking at patterns, and you can modify the number of clusters that you want and try, if I had less or more, could I make any additional use of that information? You can just go really, really deep in a lot of rabbit holes. But I'll stop right there. And that concludes the survey of Azure Synapse. And I hope you found this helpful. And again, all this code is in the GitHub repository, and the GitHub repository URL will be in the description of the video. All right, thank you for listening and watching, and until next time, take care. Bye.